Hello everyone, once again welcome to PM Networking. Guys, topic for the day is DMVPN. DMVPN. And DMVPN stands for Dynamic Multipoint Virtual Private Network. Dynamic Multipoint Virtual Private Network. And we have three phases in DMVPN. Phase 1, Phase 2 and Phase 3. So today we are going to discuss phase 1, okay, then we will discuss phase 2 and phase 3 maybe in next video, okay. But in last class we had discussed there was some problem with GRE tunnel. Suppose this is my headquarter, this is router of my headquarter. Suppose this is my branch office. Suppose we have 3 branch office, 1 2 3. All branch office and headquarter are connected through ISP. So here how many tunnel we need to create on headquarter router? This is my headquarter router, means this is my, and this is my branch office router. Suppose this is my spoke router and this is my hub router. This one is spoke 1, spoke 2 and spoke 3. So we need to create 3 tunnel on headquarter to make communication possible between all branch office. And this is first problem. Suppose there will be, if there is 100 branch in my company, right, we need to create 100 tunnel on headquarter. It's not possible, it's not scalable. So that's the reason why we are not using point-to-point GRE, why we come up with DMVPN, okay. And second problem is 2 branch office can't communicate directly, right. If you want to make communication possible between 2 branch office, 2 spoke router, you have to create separate tunnel between branch office as well, right, then only they can communicate. Otherwise branch office will communicate through headquarter. This is second problem with point-to-point GRE. And third problem is in point-to-point GRE, we are manually providing tunnel source and tunnel destination. So public IP address should be static, because suppose here I am running public IP address 11.1.1.1. Here I am running public IP address 22.1.1.1. Here I am running public IP address 33.1.1.1. So when you will create tunnel on headquarter, you have to define tunnel source. Tunnel source will be 11.1.1.1. You have to define tunnel destination. So tunnel destination will be 22.1.1.1. There will be one more destination, that is 33.1.1.1. So for this destination you have to create separate tunnel. So in this scenario you need to create 3 tunnel on your headquarter router, on your hub router, right? Tunnel 1, tunnel 2 and tunnel 3. So in tunnel 1 maybe destination will be this one. So suppose when this router will goes down and again when this router will come up, my public IP address, maybe my public IP address will be different, because I have purchased dynamic public IP address from ISP. I have purchased dynamic public IP address is not much costly, but a static public IP address is much costly, right? So if you are using dynamic public IP address, in that scenario you can't use point-to-point GRE, because on every tunnel you have to define destination, and destination should be a static, right? Then only branch office can communicate with other branch office or with headquarter, right? So this was the problem with point-to-point GRE. This is the reason why we come up with DMVPN. Now what is DMVPN? Guys, DMVPN is combination of 2 things. DMVPN is combination of 2 things. First one is multipoint GRE, and second one is NHRP protocol. NHRP stands for Next Hop reachability protocol. Okay, so DMVPN is combination of two things, multi-point GRE and NHRP protocol. NHRP protocol is protocol which is used to map destination tunnel with destination public IP address. Okay, this is a protocol which is used to map destination tunnel address with destination public address. Okay, we will discuss about these things step by step. Just wait. First of all, we have some combination in multi-point GRE, right? See, suppose this is my hub router. Okay, this is connected through ISP. This is my spoke router. So here we will create multi-point GRE, and on branch office I will create point-to-point GRE, right? So combination is multi-point to point GRE, and there will be one more combination, that is multi-point to multi-point. And in point-to-point GRE there was combination of point-to-point GRE, right? So we have three variety to use GRE. Okay, first one is point-to-point. That means on your hub side you will create point-to-point GRE, you will configure point-to-point GRE, and on your branch office you will create point-to-point GRE, right? Or you can create multi-point to point GRE or multi-point to multi-point GRE. So today I am going to discuss this variety, multi-point to point GRE. So on hub router I will configure multi-point GRE, and when you will configure multi-point GRE you can't configure tunnel destination IP address. I will show you practically as well. Okay, so suppose this is my network R1, R2 and R3. This is ISP. This is ISP. Here I will create multi-point GRE. Suppose my public IP address is 11.1.1.1 on headquarter router, and on branch office 22.1.1.1, and over here 33.1.1.1. Okay, and with the help of NHRP, see here I will create multi-point GRE. Here I will configure multi-point GRE. So you will not configure tunnel destination. Then how router R1 will came to know about the destination public IP address, about the destination tunnel address, with the tunnel destination tunnel address and destination public IP address. So a spoke router will send one registration message. Which message? Registration message. Register message. Which type of registration message it is? It is NHRP registration. NHRP registration. And in this message, branch office will register their self with headquarter router, right? That this router will tell my tunnel IP address is 192.168.1.2, whatever tunnel IP address you will configure over here, and my public IP address is 22.1.1.1. Now R1 will make entry in their NHRP map table. NHRP table. Actually, whenever you will configure NHRP protocol on router start maintaining a table called NHRP map table. NHRP map table. And in this table they will make entry like my destination tunnel IP address is 192.168.10.2 and my destination public IP address is 22.1.1.1. Okay, in the same way these router will also maintain this table, NHRP table, and we have two options to make entry in their NHRP table. First one is static. You can inject a static entry in this table as well, and second one is dynamic with the help of NHRP. So again, NHRP is combination of two things. NHRP is combination of two things. First one is NHS and second one is NHC. Next hop server and next hop client. So your spoke branch router will be NHC, means client, and your hub router will be NHS. So client will register to hub. Okay, let me show you practically, so it will be make more clear to you, right? Let me open GNS3 and let me show you. Okay, so this is my GNS3. As you can see over here, this is my headquarter router, this is my headquarter R1, this is my branch router, this is my branch router, and here between headquarter and ISP I am using this network. I am running 11.1.1.0 network, right? I will configure 11.1.1.1 over here. I will configure 22.1.1.1 over here and 33.3.3.3 over here. Sorry, I will configure 33.1.1.1 over here, right? And this is my tunnel network. This is my tunnel network 192.168.10.1. If you have watched my all previous video on VPN series, right, then definitely this video will help you a lot to understand DMVPN, right? Otherwise maybe it will be difficult for you to understand, right? So first, if you haven't watched my previous video, start watching from day one. Okay, now let me access all router and I am going to configure IP address. Here you can say this is my LAN network, so I will create one loopback, right, on every router. This is my LAN network which is connected to my branch office. This is LAN network which is connected to my other branch office. This is LAN network which is connected to my hub router, which is connected to my headquarter router. Okay, now let me take access and let me configure IP first. R1, R2, R1, R2 ISP, close it. Okay, let me access R1 as well. This is my R1. First of all, I am going to configure IP on ISP router. This is my R1, this is my R3, this is my ISP router, and this is my R2. So first of all, I am going to configure IP on ISP router. So configure terminal interface serial 2/0, no shutdown, and IP will be public IP address 11.1.1.2. I am going to configure 2 on ISP side and 1 on my edge side, on customer edge side. Okay, 255.255.255.0. exit interface serial 2/1, no shutdown. IP address will be 22.1.1.2, 255.255.255.0. exit interface serial 2/2, no shutdown, and IP address will be 33.1.1.2, 255.255.255.0. exit. Fine. IP configuration of ISP router is done. Now let me configure IP on R2, R1. Go to configure terminal interface serial 2/0, no shutdown, and IP address. IP address will be 11.1.1.1, 255.255.255.0. exit interface loopback 1. So this is my LAN network. IP address will be 10.1.1.1, 255.255.255.0. okay, and let me configure default route as well. So command will be IP route 0.0.0, 0.0.0, and next hop IP address will be 11.1.1.2. right? Now I am going to configure IP on R3. Configure terminal interface serial 2/0, no shutdown. IP address will be 33.1.1.1, 255.255.255.0. exit interface loopback 1. IP address will be 30.1.1.1 255.255.255.0. after that default root IP root 0.0.0 0.0.0 and next hop IP address will be 33.1.1.2. right? Let me configure R2 now. Configure terminal, interface serial 2/0, no shutdown, and IP address will be 22.1.1.1 255.255.255.0. exit interface loopback 1 and IP address is 20.1.1.1 255.255.255.0. exit. Now my public network is reachable to each other. Let me ping 11.1.1.1. why I am not able to ping my public IP address on R1? Next hop is this one. Let me check. So IP interface brief exclude unassign. So on serial 2/0 IP address is this one fine, loopback this one is fine, both line protocol and status is up. Ping 33.1.1.1. yes, 33 is reachable. Ping 22.1.1.1 is not reachable. Let me check R2. So IP interface brief. So on serial 2/0 IP address is 22, everything is fine. There is no default route, right? Let me configure default route, I think. Let me check. So IP route. So yes, there is no default route. Let me configure default route. IP route 0.0.0 0.0.0 and next hop will be 22.2. right? Now can I ping 11.1.1.1? yes. Can I ping 22.1.1.1 from here? yes, right? So my public network is reachable with each other, right? Now I am going to make communication possible between private to private, right? So we need to create tunnel. So on R1, first of all, on R1 I am going to configure tunnel. So on my hub router, on my headquarter router, I will configure multi-point GRE, and on my spoke router I will configure point-to-point GRE. okay, and on multi-point GRE you can't define destination. okay, so see interface tunnel 1. After that IP address will be 192.168.10.1 255.255.255.0. after that tunnel source will be 11.1.1.1. after that tunnel destination. So you can't define tunnel destination. See, yes, I am able to define tunnel destination also, because by default GRE mode is point to point, right? Okay, first of all GRE IP GRE, okay, tunnel GRE tunnel mode GRE, after that multi-point. This is command to configure multi-point GRE, right? And once you will configure multi-point GRE, you can't define destination. Tunnel destination 22.1.1.1. See the error message: tunnel destination configuration failed on tunnel in mode multi GRE, right? So on multi GRE you can't configure destination, right? Now let me configure NHRP protocol as well. So command to configure NHRP is very simple: IP NHRP, after that network ID. And network ID is similar to like process ID in OSPF, right, which is used to identify the process, and it is locally significant. You can configure anything. Fine. This is the command to enable NHRP. Okay, now let me create tunnel on R2 interface tunnel 1. This is similar like point to point GRE. We have discussed these things in previous video. After that, IP address is 192.168.10.2 255.255.255.0. after that, tunnel source is 22.1.1.1, and here I am running point to point GRE. So here we need to define destination as well. Destination will be 11.1.1.1, right? After that, let me configure NHRP, IP NHRP, network ID, suppose 2. You can configure anything. This is locally significant. In the same way on R3, let me create tunnel 1. IP address is 192.168.10.3 255.255.255.0. IP NHRP, okay, sorry, tunnel source is 33.1.1.1 and tunnel destination is 11.1.1.1. fine. After that, IP NHRP network ID. This is command to enable NHRP protocol. Fine. Now, can tunnel to tunnel communicate? Can I ping 192.168.10.1 from here? No, I am not able to ping. Why? Because ICMP request will be generated at router 3. Source will be 192.168.10.3 and destination will be 10.1, right? So this router will check their routing table to forward traffic in which network? In this network. So exit interface will be tunnel 1, and whenever router will forward traffic on tunnel interface, router will add one extra header, right? That is GRE header. In GRE header, source will be public IP address, that is 33.1.1.1, and destination will be destination public IP address, that is 11.1.1.1. So IP NHRP. Where is destination public IP address? Where is destination public IP address? So guys, here is one concept, that is whenever you will configure NHRP protocol on router will start maintaining a table called NHRP map table, right? In map table, they will make entry about the destination tunnel address. Destination tunnel address is 192.168.10.1. After that, destination public IP address, that is 11.1.1.1, right? So again, we have two options to inject entry in NHRP map table. In NHRP map table, first one is static and second one is dynamic. Why tunnel to tunnel communication is not happening? Because router don't have destination IP address, right? So how router will add external header, external GRE header? This is the problem. Fine. Now let me inject this entry manually in NHRP map table of every router. In next video, I will show you how to make entry dynamically in NHRP map table. And you know what we called it to destination public address? Destination public IP address is just wait guys, just give me 1 minute. Okay, so this IP address will called as NBMA address. Okay, so let me inject this entry in NHRP map table manually. Go to interface tunnel 1. After that, IP NHRP map. After that, you can see destination address. So destination address is 192.168.10.1. after that, destination public IP address, NBMA address, sorry, this is called NBMA address. This is called NBMA address. NBMA address means my destination public IP address, my destination public IP address, and destination public IP address is 11.1.1.1. After running this command, you can check this table. So IP NHRP, this is a command to check NHRP table, and here you can see my destination IP address is 192.168.10.1 and my NBMA address is 11.1.1.1. this is my destination public IP address. Now can I ping my destination tunnel 192.168.10.1? No, because in the same way on your headquarter router you have to map destination tunnel address with destination public IP address. So go to R1 and let me run the same command over here as well. IP NHRP map 192.168.10. Earlier I have configured on R3 now. Okay, so destination will be 192.168.10.3. after that, NBMA address is 33.1.1.1. now go to R3 and let me show you. You can see now I am able to ping. Success rate is 100%, right? Now I am able to ping my destination tunnel. In the same way on R1 you have to map one more entry in NHRP map table. So IP NHRP, see there is only one NBMA address, right? So you have to map other NBMA address, that is 22.1.1.1. okay, so go to configure terminal again, interface tunnel 1 IP NHRP map, and this time my destination is 192.168.10.2. and I will show you how router will automatically inject entry in their NHRP table as well. Okay, this is day 1 of DMVPN, so that's why I am configuring, I am injecting manually entry. Okay, and destination NBMA address is 22.1.1.1. now you can see how many entry are there. So IP NHRP, there are 2 entry right now. First one is 192.168.10.3 whose NBMA address is 33.1, and second tunnel, destination tunnel, is 192.168.10.2 whose NBMA address is 22.1.1.1, right? In the same way on R3 we have to map this entry in interface tunnel 1 IP NHRP. After that map 192.168.10.1 is my destination tunnel IP address, and NBMA address is 11.1.1.1. so IP NHRP, you can see there is one entry, right? Now can I ping my tunnel, destination tunnel 192.168.10.1? yes, I am able to ping. Can I ping? Yes, I am able to ping both tunnel, right? Still my LAN user are not able to communicate with each other. Go to R1, let me show you. Ping 20.1.1.1, source is 10.1.1.1. still my LAN is not able to communicate. So here what we can do, why I am not able to ping now, why 20.1 is not able to, sorry, why 10.1 is not able to ping 20.1? So what will be the source? Source will be 10.1.1.1 and destination will be 20.1.1.1. Router will check their routing table, right? And in their routing table there is no any network 10.10 network or 20 network, sorry, 20 network and 30 network, but there is one default route. So router is forwarding traffic towards ISP router directly, right? So I have to inject this network in the routing table, this network 20 network in the routing table of R1 with exit interface, tunnel interface. Then only router will add external header, that is GRE header. So here what we can do, we have two options, static routing and dynamic routing. In last video I think I had implemented a static routing, right? So here I am going to configure dynamic routing. Let me configure EIGRP. Okay, router EIGRP AS number 100 and network. Let me run no auto summary command, no auto summary, and network is 192.168.10.0, right? In the same way on R3, router EIGRP 100 and network is no auto summary, and network is 192.168.10.0. in the same way on R2 as well. Let me configure EIGRP. Router EIGRP 100 no auto summary and network is 192.168.10.0. so IP EIGRP neighbor, there is no any neighbor, so IP protocol, right? I had advertised this network, but why there is no neighborship? Let me capture one link. Let me capture this link. So router 1 is sending hello message or not? Yes, definitely router 1 will start sending hello message. You can see who is sending this hello message. Source is 192.168.10.1 and destination is multicast. Oh, destination is multicast. So in GRE header you can see GRE header destination is again multicast. So this is the problem, right? This is problem. Router is sending hello message on multicast address. So you have to tell to router that send hello message on unicast address. You have to tell to router that send hello message on unicast address. So command will be simple, go to interface tunnel 1, after that IP NHRP map, after that map, and whatever multicast address will be, don't send any message on multicast address. Send, instead of putting multicast address in destination IP field, put this IP address 22.1.1.1 and 33.1.1.1. okay, now guys let me show you capturing data. So now R1 is sending hello message. This is hello message of which router? 10.2. This is hello message of 10.3. This is hello message of 10.1. Now you can see in actual IP header destination is multicast. Sorry, this is okay. This is previous hello message, I think. Here you can see who is sending this hello message. Router 2 10.2 and destination is multicast, but in GRE header you can see destination is unicast, right? Now if I will show you EIGRP neighbor, so IP EIGRP neighbor. Okay, on R2 we need to run this command as well. Interface tunnel 1 IP NHRP map multicast to 11.1.1.1. so IP EIGRP neighbor. So IP EIGRP neighbor interface tunnel 1 IP NHRP map with multicast to 11.1.1.1. So IP EIGRP neighbor, there are two neighbor now, right? Both are on tunnel interface. In the same way on R3 you can verify it. So IP EIGRP neighbor let me capture this link. So on R2 there should be EIGRP neighbor. Capturing between R2 and ISP. This is update message. Where is hello message? Let me open hello message. Who is sending 10.2 on multicast address, and in external IP header destination is 11.1.1.1. The source is 22.1.1.1. I think there is some misconfiguration on R1. So IP EIGRP neighbor. Okay, so IP NHRP, everything is fine. Wait guys, so running configuration interface tunnel 1 IP NHRP map 10.3 with yes, this one is fine, this one is fine, source is this one fine, so everything is fine over here. Interface tunnel 1 IP NHRP map multicast, after that 22.1.1.1 and 33.1.1.1. So IP EIGRP neighbor. So IP EIGRP neighbor. Yes, there was some misconfiguration on router 1. So IP EIGRP neighbor. Now everything is fine. Yes. Now you can check on R1. There are two neighbor. Both are on tunnel interface. Both are on tunnel interface. But still there is no route for 20 network and 30 network in the routing table of R1. So what we need to do now, we need to advertise my LAN network in EIGRP. Then this router will send update message, right? So let me advertise LAN network of every router in EIGRP. Command will be router EIGRP 100 and network 10.1.1.0, right? On R3 router EIGRP 100 and network will be 20.1.1.1.0. Sorry, network will be 30 dot na. On R3 network will be 30.1.1.0. On R2 configure terminal router EIGRP 100 and network will be 20.1.1.0. Now guys, let me show you the routing table of R1. So IP route. So yes, now there is 20 network with exit interface tunnel 1, and there is 30 network with exit interface tunnel 1. That means now I can ping my private network 20.1.1.1 and source is 10.1.1.1. See, now I am able to, now my LAN user are able to communicate with other LAN user who is sitting in different network, right, on different branch office. Okay, but in the routing table of R2 and R3, so IP route, will there 30 network in the routing table of R2? See guys, no, there will be no 30 network. Why? Because of a split horizon. Because of a split horizon, router 1 is receiving this network with the help of update message on tunnel 1 interface, right? So rule, remember the rule of a split horizon, that router will not send same update on the same interface, right? So here we need to disable a split horizon. So go to interface tunnel 1. After that, no IP split horizon EIGRP 100 for EIGRP 100. Okay, neighbor bill goes down and then neighbor bill come up again. So IP route. Now here you can see 30 network, 20 network, 10 network, right? For 10 network, exit interface is tunnel 1. For 20 network, exit interface is tunnel 1. Now my LAN user can communicate with other LAN user 30.1.1.1 and source will be 20.1.1.1. See, source is okay, sorry, destination is 20.1.1.1 and source is 30.1.1.1. yes, I am able to ping. So this is phase 1 VPN, this is phase 1 VPN. And if I will trace route 20.1.1.1, see, my traffic is going through hub router. Still there is some problem, right? First traffic will reach to hub router, then hub router will forward to router 3, to other branch router. Okay, we will discuss these things in next video, otherwise video length will be large. Okay, so that's all for today. This is phase 1 DMVPN. Thanks for watching. If you like this video, please hit on like button. If you haven't subscribed my channel, please subscribe this channel. We will meet soon in next video. Till then, stay safe guys. Bye bye everyone.